Hi, I'm Zhichun from the Chawla group. I want to introduce about the training procedure using neural network to do reaction prediction. And here is an example of the reaction. And what we need to do is to take these two rectangles and also base, ligand, and other conditions as input for computers, also neural network algorithm, and then I will let them to predict the product of the reaction. So the first step, we need to define a graph which can represent these rectangles and also base ligand and base ligand and other conditions. And also this graph can be learned by the computers. As Bo Zhao introduced, he introduced about how to clean the data set and how to convert the raw data to model readable data set. And in this step, I will introduce how to prepare your data sets to be readable for computers in details. And then I will introduce how to learn the knowledge from the graph structure. When you see this molecule, maybe you can know what's the property of the bonds and what's the property of this molecule, but how can we let computers know what's the knowledge it contains in this graph? And the final step, I will introduce how to utilize the knowledge you learned from the graph structure to do the prediction for the products of the reaction. The first step, I will introduce the how to define the molecular graph, because if you only want to use some existing neural network to do prediction, maybe this step is the most important for you to know. So I will introduce what is the molecular graph. It is a labeled graph whose nodes correspond to the atoms of the molecule and the edges correspond to the bonds. So I will introduce the very famous and common ways to define the molecular graph. We will define the molecular graph as G. It contains 4 parts. And I will take this molecule as an example to introduce these 4 parts. The first part is A. A is the set of atoms. In this molecule, there are 10 atoms. So A is a dictionary, and it will contain 10 numbers from 1 to 10, and each number will represent a specific atom in this molecule. And X represents the atom content matrix. So what is atom content matrix? It is the matrix which contains the features or information of the nodes, such as types of atoms. And I will give you an example. This is an example of the content matrix. And because in this molecule, there are 10 atoms, so there will be 10 rows in this matrix, and each row will represent the specific atom corresponding to the atoms in A. And you can see each row is a vector. We also call this vector as embedding or representation. It means the information of the specific atom is embedded in this vector, or this vector can represent the specific atom. And you can see that the same kind of atoms will share the same initial embedding, like the color circles shows. The same kind of atoms will share the same color circles. And then we consider, you can see that in this matrix, it contains the information about the atoms types. And for the simplest way to do the initial embedding is the one-hot embedding. So what is the one-hot embedding? One-hot means a group of bits among which the legal combination of the values are only those with a single high bit and all the others low. And I will also show you an example. Like this matrix shows, this is the content matrix which is embedded by one-hot embedding. So I suppose there were 10 different atoms in the whole graph. So there will be, there are 7 different atoms in the whole graph. So there will be 7 columns of this matrix. And each column will represent the specific atom types. So in this matrix, the first row represents the first hydrogen in this molecule, and we can see that the sixth column represents the hydrogen. So in the first column, in the first row, the sixth column will be 1 and others will be 0. So this is the way how to do the initial embedding, which named one-hot embedding. And then I will introduce what is B. B is the set of bonds. So in this molecule, there are 10 atoms. So this B will be, B is a matrix and it will be 10 rows and 10 columns. In this matrix, there will only have 0 or 1. If it is 0, if it is 1, it means there is a bond between these two atoms. And if it is 0, it means there is no bond between these two atoms. And from this matrix, you can see there are 10 bonds in all. And then I will introduce Y. Y represents the bond content matrix, which is maybe similar with X. It is the content matrix which contains the information of the bonds. So this is the left matrix is an example of the bond content matrix. There are 10 bonds in this molecule, so there will be 10 rows in this matrix, and each row represents a specific bond. And you can see that from the first bond and to third one, and also the last one are single bond in this molecule. So they share the same initial embedding. From the 4 to 9, there are the bonds in the benzene ring. So I consider it as 1.5 bond. So they share the same initial embedding. And the right matrix is an example of the bond content matrix, which is embedded by one-hot embedding. I suppose there are 4 different bond types in the whole graph. They are single bond and the bonds in the benzene ring, and also double bond and triple bond. And so there are 4 columns in this matrix, and you can see the first row represents the first bond in this molecule. It is the single bond, so the first first column will be 1 and others will be 0. So so until here, maybe you will know how to define the molecular graph. So you can know how to prepare your dataset to be trained using the neural network, and it will also be easier for you to know how to learn the knowledge from the graph structure and how to predict the product. And I will introduce these 2 steps in the next part of the training session. Thank you.